Hello, Energy Tech. I come to you on the eve of the Common Core Regents exam, figuring that while we have a chance, we might do a couple more Common Core problems just to get a sense of what you might see tomorrow. So here's one Common Core problem that we have seen in class before. As shown in the diagram below, circle A has a radius of 3 and circle B has a radius of 5. Use transformations to explain why circles A and B are similar, okay? Well, the first thing I want to remind everyone of, first of all, is that all circles are similar. Just go ahead and write that up here. All circles are similar, including these two circles. But remember, to be similar, right, what that means is that two shapes are similar if you can move one onto the other, using a sequence of similarity transformations. So what this question is asking us to do is to basically show a sequence of similarity transformations, or rather describe a sequence of similarity transformations that is going to move circle A onto circle B, okay? So to show you what that would look like, I am first, make that a little smaller. I am first going to translate the center of circle A onto the center of circle B. So if I were going to describe this in words, I would say, okay, circles A and B are similar because the following sequence of similarity transformations puts circle A onto circle B. Okay, number one. Translate circle A by the vector, and I will write this with my pen because I'm going to use the notation for it, by the vector A, B, arrow, right? And that arrow in this case is a vector sign, not a sign for array or anything like that. Okay, so now if we were to try to draw circle B, or sorry, the circle A prime on top of circle B, which God help me, I'm going to try to do now. It would look something like this. Whoa, okay. Imagine that as a beautiful, perfect circle, and you'll have an idea of what I'm going for here. But basically, that we now have a circle of radius 3 directly inside a circle of radius 5. Okay, well, the second transformation we need is obviously a dilation. And in terms of the scale factor that is going to work here, we're going to take the radius of, the large circle, which is 5. And divide it by the radius of the small circle, which is 3. Okay, so you can leave that as 5 over 3. If you want to think of it as 1.6 repeating, you can. I prefer to leave it as 5 over 3. And to sort of verify that this works, right? If I take the radius of circle A, 3, multiply by our scale factor of 5 over 3. And you can check this on a calculator. The 3's are going to cancel, and I'm going to end up with the radius of the new circle, 5. Okay? So that will always work, by the way. This is not just a 3 and 5 thing. That will always work for any two circles. So I'm going to say dilate circle A prime centered at B. Right? We want to say that the dilation is now centered right here, where the center of both circles now is, okay? Centered at B by a scale factor of 5 over 3. All right, and that is a complete and correct answer to this Common Core sample question. Best of luck tomorrow, ladies and gentlemen. Break both of your legs and your wrists and maybe your femur as well. And I'll see you tomorrow.